Hello. Hello. I'm audible? Oh, okay. Very good morning to all of you. So, all people have come? Okay. बाद में आएंगे. Okay, okay. So, myself Saket Kumar. Currently, I am working as an executive engineer in Central Water Commission. That division is Northeastern Investigation Division, which basically do the survey investigation and DPR preparation of various water resource projects. So all the people are from Assam government or some other state also?
Some and one from Neriwal.
Okay.
Some 7 participants, 6 participants are from Brahmapura.
Okay, okay, okay. Just we can have a intro, just your name and your organization, whatever organization you are, just brief we can have, so that we can understand from where and what part you are doing. So just you may start.
My name is Amul Khamara. I am supervisor from Irrigation Department.
Irrigation, Assam government. Okay.
My name is Uttam Hazarika, Assistant Engineer from Irrigation Department.
Okay.
Good morning, sir. I am Mahanmohan Thakur. I am Assistant Engineer in Irrigation Department.
My name is Ehsanullah Khan, currently working as an Assistant Executive Engineer, Irrigation Department, posted in Kuliyawat Samagari Division, Irrigation.
Okay. Okay. Yes, ma'am.
My name is Saket. I'm currently working as an assistant engineer under Reconnaissance Irrigation under Government of Assam.
My name is Nikhil Chauhan, Junior Engineer from Uttarakhand, posted at Irrigation Office in Delhi.
Okay. Delhi. So,
Good morning, sir. मैं उत्तम राजवंशी हूँ, जूनियर इंजीनियर ब्रह्मपुत्र हेडक्वार्टर में पोस्टेड हूँ.
okay. Okay. Up.
Good morning, sir.
Okay. Yeah.
My name is Saurabh Bhattacharjee. I am working as a research associate in Neriwal.
Native.
My name is Paras Kundar. I am posted in Barpeta, currently Irrigation Department.
Okay. Ma'am.
Myself, Maharika Das. I'm currently working as an assistant engineer in Government of Irrigation Department.
Good morning, sir. My name is Rahul Rama, senior engineer from Brahmapura Board, currently posted at members of Irrigation Department.
Okay. So,
My name is Akhil Gogoi. I am education engineer from Bombay.
okay. You.
Akhil Gogoi, junior engineer, irrigation department.
Okay. Okay.
My
Ma'am.
name is Poras Prasad, assistant engineer from Irrigation Department.
Okay. You may start.
My name is Bobojit Kampai. I am working as an assistant engineer, West Dimapur Division of from Irrigation Department also. My name is Bobojit Kampai. I am working as assistant engineer under Irrigation Department.
My name is Durgadhar Das. I am working Brahmapura Board.
Ma'am.
Good morning. My name is Kitimulika Bora, Faculty of Irrigation.
Okay. So, how many of you are engaged in any project where you are preparing this PFR or DPR? Is anyone is engaged any project? Or have anyone has prepared, has been the part of any PFR or DPR earlier, who has prepared the any project PFR or DPR? No. Okay, okay, okay. So my topic here is this Reconnaissance survey and basically PFR, pre-feasibility study of irrigation and multi-purpose project. So we have recently has anyone is associated with Katkal project? Recently I have submitted this project to the Assam government. It is, I think, under appraisal stage. Is anyone is engaged in that project? Okay, okay. So we'll see how we can plan the. Is anyone is saying any something? Okay, so we'll start. So basically this is the outcome of the whatever you will plan after PFR and DPR, and after construction you can see that this is the a typical diagram of the project, where you can see the reservoir, the structure, dam structure, and other all the parts of hydraulic structures. So this comes after the outcome of the construction. This is the water resource project development process. How we conceptualize and then construction happen. So first site selection and preliminary survey we do. After that pre-feasibility study, and then detailed survey investigation, preparation of detailed project reports, submission of DPR, and TAC, techno-economic clearance, then management plan and tender call, and construction period 3 to 5 years as per the schedule of the project. So this is a water resource project cycle, concept to commissioning. How we do create concept, then we plan, investigation is done, then DPR, and design, engineering, construction, and commissioning. So this is a typical diagram. I think most of you already knowing all these things, but just for sake of the basics and to have an understanding, we can see there will be some reservoir and the dam body. That is the reservoir, and here dam body, spillway, its crest, and this is the downstream, this is the upstream. So this is the basic understanding of the any project, this either a dam or barrage. So again we have come the reconnaissance and feasibility studies are the preliminary stage of the planning for irrigation and multipurpose project. This step, why we do the reconnaissance survey, to have a better planning before going into the detailed survey investigation. So before that we do these reconnaissance, and after reconnaissance we do if it is feasible or if it seems feasible, then we go for the PFR or feasibility study analysis. So systematic approach to formulate the project is to proceed for investigation in 3 stages as under reconnaissance, then feasibility report. We prepare the feasibility report. Actually feasibility report is just you can say that a small or brief DPR, where we assess the project is feasible, it may be feasible or not, and based on that we go for the DPR stage, and for DPR stage we do detailed survey investigation activities. And these are the category of projects. These are the, you can say that major a guideline based on some guidelines, or let's say that small project is CCA having more than 2000 hectare, 2000 to 10,000, then medium project, and more than 10,000 is a major project. These are the CWC guidelines, and same for the power generation also. If it is 25 megawatt, then less than 25, then small project. If it is these 25 to 100, then medium project, and capacity, if it is more than 100 megawatt, then it is a major project. And these are the CA guideline for these power generation projects. So this is a typical layout of the Sonai irrigation project. This is also a Assam project. The DPR was prepared by the CWC by my division. NEID1 has prepared the DPR of this project. So just a typical layout of its command area and dam access. Actually, before planning, I will let you know these alternate dam access. Why do we require these alternate dam accesses? I will explain later. So a water resource project, this thing I have already told you, but just for sake of understanding how we take you mean the water utilization for different purposes. Let's say barrage and weir. So intake, how we do intake for irrigation intake, we through canal, branches, distributaries, then field channels. And for power intake, it goes from head race channel, tunnel, then penstock, powerhouse, then tail race channel. Intake for drinking water, and then it goes through the supply pipelines. And this is a typical layout of a multi-purpose project. You can see here dam is there, the dam body is there. Also some construction stage parts have also shown that before this construction of this dam, the coffer dam is created, and the diversion tunnel, it is created to evacuate the water and to clear the space for constructing all these coffer dam and main dam body. And you can see that the head works from where the canal is going, and the power intake from where the water is being taken out for the power project. So it goes from desilting chamber, then headrest tunnel, then surge tank, then pressure shaft, then powerhouse, then TRT, and in the downstream it is released. And from the headworks, the water is taken out from the canals and it goes to the field channel, and in the end it is served to the command area. Now we are at Reconnaissance survey. What it is? Reconnaissance survey brought feasibility check on the ground. For that we do the Reconnaissance survey. Before investing time and resources in detailed survey, we do the Reconnaissance survey. So what is the purpose of Reconnaissance survey? To identify potential dam barrage sites, canal alignments and command area. To assess overall feasibility, advantage and constraint of the projects. To decide whether a detailed investigation is justified or not. For that purpose, this is the main, you can say the main reason that the detailed investigation, or we should go for detailed investigation or not, that we have to check through Reconnaissance survey. Now the list of activities which we do during the PFR, while creating a PFR, we do all these activities for the pre-feasibility report, the desktop study and topo sheet study, which at first before Reconnaissance survey we do desktop studies. The very first stage is the desktop study. So desktop study, or you can say that topo sheet study. Also you can have the Survey of India's topo sheet and you can study those topo sheets, and then this field investigation, then hydrological studies, topographical studies, geological assessment, irrigation and power requirement, which is irrigation planning or power requirement planning, then design, last is cost estimate, and main output is the BC ratio. We have to reach at the BC ratio in PFR so that we can say that this project is feasible. BC ratio, that is our main goal in the PFR. After that we go to the DPR stage. If BC ratio is more than 1 or it is justified, then we go for the DPR. So desktop studies and topo sheet studies, what we do in these and what we have to do. So this is the before Reconnaissance survey we do the desktop study. So for the desktop study, either you can go through Survey of India topo sheets, which are available in with the Survey of India, that you can purchase from the Survey of India, or geological Survey of India map is also, if you want, if you're or you are having an expert of geological expert, then they can utilize all these things. So then you can also, normally what we do, that we go to the Google Earth, this Google Earth Pro, and from there you can identify your location where you are planning to have the barrage access or dam access, where you are planning to have. So from there you can have a little bit idea, but there you won't find the DEM. You can generate from the Google Map also the DEM. There are methodology from DEM. You can generate from Google Earth also, but SRTM is also available. So SRTM, from the SRTM side, which is NASA is it is in public domain. So from there you can download the DEM, and you can do the analysis on that DEM, or remote sensing imagery, and Google Earth I already told. So one more thing, right now Bhoonidhi is also available. On Bhoonidhi portal you can get the DEM. If you'll go to, let me check if. Here you can get registered as an organization. So you can register. You can register as a individual also. But you please register as a organization. Then you will get you get yourself registered, and then you will get, I think, some more options are there. If you will get registered, you have to one form is there in its site. You have to mail that form, fill that form, get registered from your competent authority, and send to them. They will register you as an organization in this portal. So this is the portal. This is better than Google Earth. Google Earth you can already use, but this is better than Google Earth. Here you can download the data, DEM data. Here you can upload, either you can draw the polygon. Here you can draw the polygon, or you can upload the shape file or KMZ file here. You can upload. It will draw somewhere here, and then you can select different let's say open data. Open data, you can go for open data and price data. Price data is also there, and your resolution, very fine resolution data is also available. But for northeastern region, I have not found much data. For other zones, fine data is available, but you can get this 5 to 25 meter data, which is better than SRTM 30. So you can utilize this one, 5 meter to 25 meter, and from satellite, the Cartosat 1 satellite data you can use, and then from here then you can select the sensor type, whatever. So multi spectral you can go, and then product, from here you can select, and theme, DEM, and from there also the price data is also not that much costly. One tile data, I think it will be around 2,500 one tile with GST. So if 10 to 12 tiles are there, so it not more than will be around 70 to 80,000 for the overall AOI. For in general, if AOI area is around you can say that 50 square kilometers, then you can get around 80,000. So it is not much. So for the feasibility study, you can go through, you can utilize these data, because for feasibility study you cannot go the detailed topographical survey. But for feasibility study, one also, if the data is not available for northeastern region, the main issue is that the vegetation, so much vegetation is there. Because of that, good data is not available in the open domain and even on Bhunidhi. I have tried in some of the locations of Assam, here the data is not available. So for that, if you are creating the PFR, then I will explain the for PFR also you can go for the topographical survey. So desktop, these things are the part of the desktop study because before going to the Reconnaissance survey, you should have at least some analysis done on your desktop. So and what are the findings you will get from those desktop studies? You will locate the possible dam access points based on your river valley topography. At least minimum 3 alternate dam access should be identified on your whatever the data you are utilizing. Let's say on Google Earth you are seeing, and there you can mark some access to at least 3 axes, and I will tell why at least 3 axes are required to be identified. I will tell this in later. And then geological features which are visible from the geological map, if you can identify the geological features. River stability, if you can see from the Google Earth. Existing hydrological, rainfall and catchment data, IMD grid data that you can utilize. Accessibility, you can see nearby which what are the roads which are available nearby, so that while going during the Reconnaissance survey you can approach from those roads. Command area assessment, tentative power potential. So command area, where is the command area located, that you can identify from that data. Forest area, habitation, infrastructure likely to be submerged. Submergence area, what will be the submergence area, that you can identify from there. So for that you need to utilize any DEM data, at least either you use SRTM 30 meter or you use this Bhuvan data. If you get the Bhuvan data, then you can utilize that. Location of nearby gauge site for hydrological correlation. If any CWC has got so many sites and so many rivers, so if you can get the gauge data from those sites, so that can also be utilized for hydrological correlation. Preliminary reservoir capacity estimation. This is the preliminary reservoir estimation is done by your area elevation capacity. You have to from the DEM you can easily extract the area elevation capacity. So and that is utilized for the capacity of your reservoir. And identify the reservoir submergence zone. What will be the submergence zone? After you can decide a tentative FRL, and from that FRL you can draw a shape file around that FRL, and from that FRL you can identify the submergence zone, what are the zones which are in submergence, and other data. So this is one example for this. This is the Madura irrigation project. Currently survey investigation, my division, I am doing the survey investigation for this project. The Madura irrigation project, it is in Assam, nearby Kachar district. So this is the this I have taken from the Google Earth, just to show you the different dam accesses, which alternate dam accesses I have identified. 1, 2 and 3 dam access. 3 dam accesses has been identified. So now why at least 3 dam accesses? I was saying that at least 3 dam accesses should be identified initially during your desktop study, so that while after going there you can go at least you can visit. If one fails for any reason, let's say geological reason, or even maybe geological reason, maybe submergence, maybe the reason, because after going there you will identify the actual scenarios, what are the actual scenarios are there. That's why at least 3 alternate dam accesses are identified. So we have identified 3 dam accesses, and in which earlier we planned at axis 1 to have a barrage, but water availability was not there. Then we gone for alternate 2, but geology was not supporting, so we gone for one more alternate which is just upstream of the alternate 2, 2 kilometer. There we are creating one storage access, and at axis 1 we are creating a pickup weir. So this kind of arrangement we are doing in this Madura dam access, Madura dam, this irrigation project. So this is just for example ki you have to identify at least 2 to 3 dam accesses, so that you have a backup accesses in your plan, because sometime what happens that in some of the project it has happened that you have finalized each and everything. After that some local people will come, they will say that this some issue is there, maybe their religious place is there or something is there, so everything you have finalized, but even after that you cannot finalize that access as a storage access, then you have to move some other access. So therefore you should have at least some backup accesses. Now factors affecting selection of dams or barrage, whatever the structure you are planning. So different factors. These are very basic things I am telling to you. These are very basic things, and these points which I have written here, these are very basic guidelines. So it is not like these are fixed guidelines. These are very basic guidelines which have been written here with experience. So narrow U-shaped valley, narrow stream flowing between high rocky mountain would suggest concrete overflow dam. If it is like U-shaped valley is there and rocky walls are there, your exposed rock is there. You have gone for Reconnaissance survey and you have seen that exposed rock is there on left abutment and right abutment. So or left side and right side, then you can think of that concrete overflow dam may be planned here tentatively. Generally in Reconnaissance survey, if geologist and your design expert is there, so they should go along with you, so that you can finalize at least few things at there. A low rolling plain country would naturally suggest an earthen dam with concrete spillway. So if row rolling plain is there, then it suggests the earthen dam with concrete spillway. Dam embankment will be of earthen dam, but with concrete spillway. But concrete spillway comes with the condition that somewhere you can find the location where the concrete spillway could be placed. Otherwise you have to plan where we have to put the concrete spillway, because concrete spillway has its own weight and design. And a narrow V-shaped valley indicate choice of arch dam. Now the geology and foundation condition. So solid rock foundation, if you are visible that RBM material is there and solid rock is there, such as granite or gneiss, these can be identified by you also, or your geologist is there. If some geologist is there with you, then he can tell that the rock foundation type offer high resistance to erosion, percolate. Almost every kind of dam is possible to this type of rock. If seams and fracture are present in these rocks, they must be grouted and sealed properly. Foundation treatment is required if some fracture or rocks are there. Gravel foundation, if the foundation is gravel foundation, coarse gravel and sands are unable to bear the load of concrete gravity dam, they are suitable for the earthfill and rockfill dam. Low concrete gravity dam up to 50 meter is possible, such type of foundation. So then silt and fine sand foundation suitable for earthen dam or very low concrete dam up to 8 meter height. Rockfill dam is not suitable in such type of foundation because of seepage settlement problem. Then if the foundation is clay foundation, unconsolidated and high moisture clay likely to cause enormous sediment of dam, not fit for the concrete dam or rockfill dam. must accepted for the earthen dam, but two after special treatment. Earthquake zone structure best suited to resist the earthquake shocks without danger are earthen and concrete gravity dam. That we as we know that the concrete gravity dam and earthen dam, they are most suitable, and this is the Assam, it comes under zone 5. So for that you for all the project, any kind of project you are constructing, seismic study is must, because it is of zone 5 in the Assam and all this northeastern, mostly all the northeastern zone is in zone 5. Height of the dam, earthen dam are not provided for height more than 30 meter. If you are planning for a earthen dam, not go for more than 30 meter. Exceptions are there, but these are the general you can say general guidelines. For greater height gravity dams are generally suitable. Now spillway size and location. So spillway has this is dispose of surplus river discharge. Capacity of spillway depends upon the magnitude of the flood to be passed. So an ideal spillway site is one where the river valley narrows sufficiently to provide a natural control section with steep abutment and strong rock foundation to support the structure. The approach and discharge channel should allow smooth flow without excessive head losses. Adequate space should be available for the energy dissipation arrangements such as stilling basin. So this is very ideal condition, but in the field it doesn't happen like this. So but mostly you have to see at least there should be for the concrete spillway some rock foundation should be there, and that will be decided by your geologist. Practice of building concrete spillway on earth and rockfill embankment is being discouraged these days because of their conservative design assumption, and vigil and watch has to be kept during their operation. So it is saying that spillway on earth and rockfill embankment dam actually with earth, earthen and rockfill embankment, when concrete spillways adjoins these embankment, they have differential settlements, because your rock will settle differently, spillway will settle differently, and your earthen embankment will settle differently, and your spillway will settle differently. So for designing purpose, earlier what designers do, they used to design these spillway very conservatively, taking high factors of that there will be settlement. So large big filter should be provided so that it won't break. So that's how they used to design, but now it is being discontinued. Now we are, what we are doing, we are locating the best location where we can plan the spillway. Let's say your embankment is there, your embankment, let's say your embankment, I can write somewhere. I can write here. Yeah, some app is there to write. लिखने के लिए है कुछ, मतलब इस पे कुछ कोई ऐप है? अच्छा चलो ठीक है, ये लाइव है ना अभी? हाँ यही होगा, इसी को हाँ
इसमें लिख सकते हैं।
अच्छा मार्कर है क्या? Let's say you are planning rockfill or embankment, so and let's say you have created somewhere here your embankment. So concrete spillway is not planned in the vicinity of this. It will be planned somewhere where some rock foundation is there, or suitable features are available. So we can plan somewhere. It's not somewhere here or somewhere here. If some rock foundation is there, so it will be planned in other side. Obviously suitability should be there, that rock foundation is there, and your the downstream, it should be in the downstream side. So it is not created with this man-made embankment. This is created with that natural embankment which is already available. Now field investigation, ground truthing of what was seen in the desktop and topo sheet studies. Whatever you have seen in the your desktop and topo sheet, that we do. This is basically the Reconnaissance survey. So site inspection. Now we will verify those dam accesses which you have identified in your Google Earth Pro or some other satellite data. Visit the potential dam access locations. All the locations which you have identified, you have to visit all those locations physically. Verify the suitability of the topography for storage and command area coverage. If the storage is required, if storage is not required, your water availability is such that storage is not required and you can fulfill your command area with that run of the river, then you can plan accordingly. Check accessibility. So those accessibility which you have seen on the Google or your satellite data, those are available or not. Then geological assessment. So visual assessment of rock outcrops, river, bank and valley slopes. Identify foundation conditions. Now the riverbed material, if it is open, water is not available, then you can identify foundation condition. How is the foundation condition? Presence of fault or joints or weak zones. Note availability of construction material, sand, aggregate, stone, clay for core. So these are the construction materials are available nearby, or RBM material is available, so that you can utilize these materials. Hydrological and river behavior. Observe river flow, regime, sediment load and flood marks. Note seasonal variation and flood tendencies. Reservoir and submergence area. Where will be your reservoir and where will be your submergence area? That you have to identify after visiting, in the Reconnaissance survey. Environmental and social aspect. Preliminary check on forest, wildlife areas. If wildlife areas are there, that you have to identify in the Reconnaissance survey. Otherwise, at a later stage, they will you will go for detailed investigation for DPR purpose, and some forest area or some reserve area will be there. They will create issue that this project can't be feasible here. So environmental and social aspect. Your canal alignment and command area. From where your will be, your command area will be there, and from where you will take out your canal. So that you have to identify. This sometimes creates some issues. So that's why during the Reconnaissance survey you can identify where will be your structure. Let's say that you are planning your structure somewhere. Let's say it's a storage dam, and you have planned somewhere your storage somewhere here, and you are keeping your let's say storage is creating an MDDL. You have decided to be kept at let's say 90 meter or let's say 80 meter, and your command area is somewhere here, and the average elevation of your let's say the tail end of your command area is here. You have to serve here also, and let's say tail end you have identified the patch of command area, and average elevation of that patch is around let's say 40 meter, and overall you have identified that your command area average elevation is around, but your your MDDL it is coming around 80 meter because of all those sedimentation study. MDDL is fixed by the after doing the sedimentation study with the life of the reservoir. Let's say we have identified that we have calculated that for this structure will be around for 70 years or 50 years, and for that from the sedimentation study your new zero elevation is calculated, which is coming around let's say 80 meter. So you have to keep your MDDL at least above 80 meter, and this command area may be above of this 80 meter. It may be possible that topography is such that your command area is little bit higher, then you have to increase your MDDL so that you can serve this command area. Otherwise, if it is very, let's say 20 meter difference is there, sometimes this difference is more than 30 or 40 meter also. This is very high, MDDL is at very high, and this is at very low level. What arrangement we plan, we create storage here, water storage is created here, and if topography is not suitable for canal alignment because of so much huge difference between your MDDL and your this command area elevation, so what we plan at somewhere at in the downstream we plan a pickup weir, and from there that pickup weir we create all the headworks and canal alignment. Let's say it's around 8 to 10 meter head of water is created here, a pondage is created here, and let's say 80, it might be around 65 or maybe 68 meter, and from there your canal alignment can be very easily done from this area. So this kind of arrangement is also planned if it somewhere, because in the one project damming in Meghalaya, so we are dealing with it where we have found that this kind of issue is there. Sometimes topography is not suitable for your canal alignment, so that your headwork cannot be taken out from dam body itself, then you have to plan like this. Canal alignment and command area, okay. Then hydrological studies. So for hydrological studies in CWC we have hydrology, our hydrology directorates are there who are expert in doing these hydrological studies. So what we do, the water availability study, the flood study, which is basically flood design study, sedimentation studies. So these are the main studies which they do, or type of hydrological input required for simulation for different purposes of the project. Multipurpose, it may be for irrigation, hydropower, navigation, water quality control, or flood control, surface to groundwater recharge, or multipurpose. So we do the simulation studies for irrigation simulation study, hydropower simulation study. So what hydrological inputs are required for those doing those study? These are the inputs. Water inflow, let's say irrigation simulation. I will show you irrigation simulation. We do how we do the irrigation simulation, and accordingly, if it is hydropower plant, then hydropower simulation is done. So these are the general input. Apart from these, the simulation studies, hydrological input required for the studies other than simulation. So what are those? Design flood for safety of the structure, design flood for diversion, energy dissipation arrangement, sitting of riverine structure, that is sedimentation, tail water rating curve, with year over the year storage, either over the year, within a year you are creating a storage for just 1 year, or any kind of dam, any kind of project, design flood for drainage work. So these are the, in general, you any kind of project you are planning, mostly I think in multi-purpose we plan for irrigation, drinking water, and hydropower. So irrigation and drinking, these both are done. If it is your irrigation planning, then irrigation simulation, then both are done in that, both are accounted for in that simulation. Minimum length of data required for simulation studies for various types of projects are given in the following table. So data which is required for divergent project, 10-year data, within the year storage project, 25-year data. That data is of whatever, let's say your rainfall data, or gauge, you have, if you have installed the data, installed the gauge site there, from there you can get the data. And if over the year storage projects, then 40 years. Complex system involving the combination of above depending upon the predominant element. So in general what happens, that this much of data is not available anywhere. You won't get the actual data of the site. So what we do, that yearly rainfall grid data of 25 degree, which you will find IMD gridded data on the IMD site. From there we take this rainfall data for calculating this PMF, probable maximum जो flood है, and SPF, and 1 in 100 year. So for design purpose, these are the, if we are for a small project, we go 1 in 100 year flood. For large project we go for SPF, and this is for medium. And for large project having storage more than 60 MCM, we go for PMF. And these are the design criteria as per the IS codes. So accordingly we do design of the structures. So, and water availability series for the project may be estimated on the basis of rainfall series, appropriate runoff coefficient using Strand's table, English or Lacey's formula or Khosla formula, whatever empirical formula you want to use. Now the topographical studies. ब्रेक हो गया क्या? So break time. Okay. Topographical studies. So in general, if your data is sufficient, then it is okay. Otherwise, in case of the PFR, also topographical strip survey at barrage dam location covering backwater effect is likely to extend from structure 4 to 5 km in the upstream side, because that will cover your reservoir area, and 1 km downstream from the headworks with strip width of 1 km using photogrammetry, lidar technology, or UAV drone or eco sounder for your bathymetric survey. So topographical, if your data is not available, which is the case in the northeastern region, you won't find good quality of data for northeastern region because of heavy vegetation. You won't find good data. So it is better to go for the strip survey, survey of topographical strip survey. So that you can do that you from your axis 4 to 5 km upstream, so that your reservoir will be covered, and 1 km downstream. So that much, and your 1 km of width. So that you can cover. That I think 5 km and 3 lakh to 4 lakh around 3 to 4 lakh. You can get this through drone. You can do this. But in north for detailed for DPR also you have to go for the detailed topographical survey. So while doing the topographical survey or planning the topographical survey in the north, especially in the northeastern region, you go for the lidar based this topographical survey, because in photogrammetry in most of the cases in plain areas the vegetation is not too much, so there the photogrammetry works very well because vegetation is very less. But in northeastern region it won't work. What happens that a lot of patches of the command area you will get photogrammetry, you won't differentiate between the elevation of trees or vegetation and elevation of ground elevation. So there will be huge mistakes while planning your canal alignment on all these things. So always go for the this lidar based topographical survey. But lidar also contains with it this one to photogrammetry also, because ortho image is also required. So for ortho image you have to go for the photogrammetry, and for this one the actual DTM, that digital terrain model, which is created by the lidar point cloud. So for that lidar is good. So at least northeastern region, for the Assam region you go for the lidar based survey. And for bathymetric survey is also required for bathymetry survey, because bathymetry at least at your dam axis location upstream and downstream, at least 5 kilometer upstream and downstream, that data is very critical. So for that, for covering that also, you will give let's say you have awarded the tender and you are not following up, they will create the data from the lidar without taking the bathymetric survey. Because what happens in bathymetric survey, they will either you have allotted the eco sounder, but at that time when he is doing the topographical survey, he will find that water is not available in the river, eco sounder won't work, then sound pole are required. So manually from sound pole it should be covered. But what they will do, they will provide you after tender, they will manually close the contours, or they will manually draw the contours, and won't provide you actual bathymetry of the river. So these things are to be during the operation or during the doing these things, someone should closely watch that they are doing the proper bathymetric survey or not. So and this is the topographical survey data is the backbone of all your datas, because everything your from DTM, DEM, all the your canal alignment, everything you have to do on this only. So this is the backbone of your overall DPR. Every data is connected with all the drawing, everything will be from here. Even the design drawing, they will the design people, the design expert, they will do all the planning, everything on the bathymetry of the river, because you have to let's say sit the barrage structure or dam structure on the bathymetry data. So these are very critical things. So in this you he will at least you should get one ortho map and this DTM data. This the scale of the contour interval is 0.5 meter, and these are the requirements. So requirement you can get at least 0.5 meter interval contour. They will provide you, or you can draw from DEM. Once you get the DEM or DTM, then you can create any contour or any data, any kind of drawing you can create from the DTM. So has anyone ever utilized the DEM data? Has anyone done analysis in DTM? or DEM? Okay. So that in ArcGIS you can do in ArcGIS. ArcGIS, has anyone experience in ArcGIS? No. But you have anyone, any expert or some geologist or hydrologist or in the okay. No, but you can learn it. It is not that much, because opening and seeing the data, at least that much you should know. At least you can open the data, whatever the file you have been given. So at least you can open, or you can see the contour files, or where the, at least you should know this. And you can get the cracked version also, if it is it is not purchased version is there, then cracked version also you can get, and you can hands on it. So it will give benefit. At least you can this topographical and all the data they will provide you. But why, for checking the deliverables of these tenders, you obviously will do tender for all these things. They will provide you deliverables, all the deliverable which you will draw. But for seeing at least those deliverables, that they have provided or not, at least you should know. The survey should indicate all the topographical details such as road, rails, teleport, electric poles, houses, huts, important landmarking, forest areas, etc. The it is talking about the ortho. One ortho image will also be given by the topographical survey agency who has done the topographical survey. So all these elements they should clearly mark, because it will be utilized in the canal alignment while you will be doing the canal alignment. So there all these things will be required, that where is the road, where is the rail track, where is the electric pole, where are the houses, each and everything they will classify. They have their softwares, and manually they will classify, and they will provide in the legend that what are what. Geological features visible on the ground such as firm bank, rock crop, these all should be there. Bathymetric detail, water line shall be marked on the survey plan, but contours should continue in the riverbed. Contours should be continue in the riverbed and indicate the riverbed elevation. Tributaries, flow, bifurcation, deep channel, island shall also be clearly indicated. So these are the basic requirement which are required from these topographical agencies, because these are done through the via tendering, as we all know that they will do through this drone and all the equipments. So this is the basic just photograph to show that how they do it through drone. They will put one optical instrument is there, and one lidar is also attached with it, so that provide the topographical data. And this is a typical ortho diagram. All the buildings and structures they have marks, roads they have marks, and all the agricultural field, where is the agricultural field, where is the barren land, they will classify the different things. So this is the ortho they will provide. One ortho and one DTM and or DM. So these two are basic deliverables. So now the outcome. So outcome of this topographical survey: final list of all control point, benchmarks and reference point with coordinate with their location with respect to existing road or other permanent features for easy identification. Georeference AutoCAD drawing, they will provide you the georeference AutoCAD drawing. You can also do by your own, but they will provide area elevation capacity curve for the reservoir at the proposed project site. Whatever the dam site you have tentatively finalized at dam, or you can include that all three dam axes, you can provide the area elevation capacity. Once you have the DM, then you can do anything. You can do it. This is very easy in the ArcGIS. You can very easily at any location. If you have the DEM, then at any location you can evaluate the area elevation capacity. Cross section and longitudinal section of the river really showing the features described above. All the features, cross section and L section and cross sections of upstream and downstream of the project site. So now topographical survey, now we'll talk about the geological assessment. So what is your break time? 11:30. So then geological assessment, regional geology. So what happens that in CWC, how we do the geological assessment? We do a MOU at PFR stage itself with the GSI. We so GSI is involved at very initial stage with one GSI and one our design expert. So from the headquarter we have our design experts. So these two people joint visit is conducted at the project site, and they actually assess and they prepare the preliminary report regarding those access, and they provide that how the how much it is suitable for geologically suitable. So that you can do if you can do MOU, either you can do MOU with the GSI or you can go for private agency. If geologists are there, then you can, and you have confidence that geologists have enough experience. We in CWC we don't do this by outsourcing. We go by the GSI because they are the expert, and we believe in that GSI, CSMRS, and all these the expert agencies, we prefer to them as per guideline. One guideline is there of CWC for DPR preparation. 2010 guideline, I think it is to be revised in 2021, but I think it has not officially come out. So 2010 DPR preparation guideline for River Valley project 2010, it is still in the public domain. So as per that guideline also, the guideline clearly mentions that preferably these activities, the GSI, CSMRS for the these foundation study and geotechnical study, and CWPRS for the seismic study. So these should be preferred. Otherwise, if any other institute is also there, you are open to go, or you are open for this outsourcing also. So geological mapping based on the topographical contour data, 1:1000 scale, river exposure, bank slope, type of rock exposed, tentative overburden thickness, dip amount, direction, rock mass quantity, weathered, fresh, weak, or which kind of rock is there. UCS, they will estimate it using geological hammer and physical appearance. They are the experts, so they provide all these data in their report. And rock mass quantity designation, rock mass rating, estimated using the criteria. Geologists suggest to conduct the laboratory, and also this is the very important part of the geologist. Geologists suggest to conduct laboratory in situ tests. Physical parameter like bulk density, specific gravity, density, water content at saturation, apparent porosity, and all these modulus of deformation, point load strength, triaxial compressive strength, C and phi under dry and saturated condition, and shear test, etc. on selective core samples of different rock types before finalization of the appurtenant structure of the barrage and dam body as per the requirement of design. So this is about the drilling part of the, because at the excess of the, this is a part of basically the detailed survey investigation when we do drilling at the project site. Project site we do drilling, and at that time the core logging is done. At that time the geological expert from GSI and CSMRS, we call them. They will do all kind of testing. For CSMRS we send the core log. I will show you the core logs, which type of core log comes after and some of the core log we sent for testing in the laboratory to the CSMRS, and some of the core logs the GSI people come, they do in situ test. So apart from drilling, drift is also suggested. If dam height is more than 36 meter, 36 to 40 meter, then drilling is suggested. Drifting is suggested. Drifting is horizontal drilling, basically. So, and also for cavities such as deserting system, underground powerhouse structure, even sometime for intake and audits, the drift facilitates a large sample of foundation rock and allows geologists to penetrate deep inside the rock formation, which permits precise determination of nature and orientation of these structural elements. So drifting is required where dam height is more than, let's say, 36 meter. General guideline is that 36 meter height is there, then more than 36 meter height is there, then drifting may be suggested by the geologist. For dam up to 30 meter height, exploration by trial pit trenches for dam up to 30 meter. Generally 30 meter height is above 30 meter is high height dam. So for that, below 30 meter up to 30 meter height, exploration by trial pit trenches and drill holes should be sufficient. For dam up to level of 100 meter height and above, additional exploration by drift and shaft may be required depending upon the geological complexity of the site. Sometimes so many surprises comes in during the drilling also. It comes out that earlier it was in stage that there will be the rock, because exposed rock was there, so geologists suggest that there will be rock, but after drilling it is found that there is no rock. Then you have to change the strategy accordingly. Then spacing, how much is spacing for dam less than 30 meter in height, exploration by pit by at a spacing of 250 meter to 300 meter, depending upon the nature of foundation material may be necessary. It is also decided by the geologist. How much spacing should be provided, that is decided by the geologist. For dam over 30 meter height, the spacing between drill hole may be decided so as to have minimum 5 number of drill hole, with particular attention being given for adequate coverage to deeper sections. In between drill hole location, trial pit or auger holes would be sufficient. Spacing location, exploratory holes, pits and auger holes may be located along the axis of dam for dam up to 100 meter height. For dams greater than 100 meter, however, additional line of holes may be necessary depending upon geological condition. So in general, what happens if up to 30 meter height, in general, one hole in the left abutment, one hole in the right abutment, 2 to 3 hole at the riverbed level. So around 5 holes are in general suggested by the geologist, that 5 holes should be there. If in case geology is not that much good, then they will also say that one drill hole in the downstream and one drill hole in the upstream. Right? So total 7 holes they may suggest. And also it depends, some more holes, and also the height of the hole may be is also decided by the geologist. How much height means length of the drill, how much drilling length is required. And depth of overburden and depth up to which weathering of bedrock has progressed. Exploration should be carried to a depth to locate all weak and compressible or otherwise desirable layer in the foundation, such as buried channel. The depth would be generally guided by the permeability characteristic of the strata. It may be sufficient to explore up to depth of 1/3 or half of the hydraulic head at the location of the dam. If rock is found at shallow depth of less than 1/3 and 1/2 of the hydraulic head, if the depth of rock is larger than 1/3 and 1/2 of hydraulic head, 1 or 2 drill hole may be taken down to 10 meter into the in situ rock. So these are the criteria which are given. These are the very general guideline. Your geologist may suggest otherwise also. So this is one project, Geological Survey of India, Kunti Short Reservoir Scheme, it is of Jharkhand. They will provide this kind of a sheet for the your after drilling. They will provide all the size of pieces, size of core pieces, structural conditions, recovery of core, rock quality, and all these things they provide. And how they do, these are the first one. This one is the core locks. These are preserved. These are, I think it is a Katkal project. So for that, core logging has been done, and these are preserved for testing and for transportation. And this is the left side, the core drilling on floating platform. When water is there, then on floating platform we do the core drilling. And this is drilling on the dam axis. So this is how they do the drilling on the dam axis. And these core locks are taken up to a depth of 10 to 30 meters, depending upon the geology at the location. So now the geology part is basically done by the GSI. In our case by GSI, and in your case, if you are in state government, can do MOU with the GSI, or they can go for outsourcing also. Because nowadays I think the people are this geologists are available in for outsourcing also, so you can go for that. But in CWC we prefer GSI. We have not gone for the outsourcing. The purpose of irrigation, now the data required for the irrigation planning. So we do the irrigation planning. So for the irrigation projects. So anyone have any question till now? Because this session is now you are not doing any kind of questions. So keep on asking. If anyone have any doubt, and you can ask in the between if you want to ask. No one has is involved in any kind of Assam government has created any PFR by itself. Anyone have any idea? Or DPR? Data required for irrigation planning. So now we will talk about the irrigation planning, how we do the irrigation planning. So purpose of irrigation planning is to estimate the crop water requirement and finalize the design discharge of the canal. This is basic purpose of the design discharge of canal. Based on that, the canal design will be finalized. So the field data required are, what are the field data which are required? Existing proposed irrigation facilities in the proposed command area, existing cropping pattern, existing area under the rainfed cultivation, area under each crop, water availability as per hydrology. So water availability, either your hydrologist will provide, or you can outsource it for the your plant project. Irrigation intensity. Now the climatological data required for the irrigation planning. All these kind of data is required for irrigation planning. Crop water requirement calculation we do through these steps. These steps you will get crop water. I think all of you are civil engineers. So crop water requirement you would have calculated in your I think in civil engineering. So this is not I think you have already studied it. So though these things we do. Now it is a CropVat software is there. So you have done through CropVat software, or you have anyone has used CropVat software? So for the irrigation planning, we do the simulation study. For the irrigation, I will show you one detail sheet also for simulation study. Overall success of a project is checked by means of matching the availability of the water with the demand in reservoir operation working table. For a storage project, these tables are required to be prepared for a period of 20 to 40 years on monthly basis, and that for divergent project for a period of 20 years on 10 daily basis to assess the success rate of the project. The desired success rate of for irrigation purpose is 75%, 100% for domestic water supply, and 90% power project. These are the general guideline. Is success rate should be for the success rate for irrigation project 75%. If it is of domestic water supply, that drinking water, then it should be 100%, and for power project it 90%. So this is a example of, I will show you one Excel sheet also we have prepared for the calculating the simulation study for different projects. So this is a typical picture has been taken from there, that starting gross capacity, then how much inflow is coming, then drinking water demand, how much drinking water demand is there, wildlife demand, irrigation water demand. In the irrigation water demand, that is calculated from the irrigation demand, industrial water demand, then your total demand, evaporation loss, final loss, and spillage. This is the spillage, and final reservoir level, how much the reservoir level is maintained. For power project, we do the power potential study. As for irrigation purpose, we do simulation study for irrigation. So for power potential study, source wise available, generating capacity and utilization in the state region, power requirement, future plan for power development, benefit from the proposed project, powerhouse and equipment, transmission arrangement, installed capacity, power benefits, capital cost. So this is very basic preliminary calculation for power potential, that which is very crude. You can say that this is the very crude calculation. Simulation study for power is done based on these preliminary calculations. So power potential study is also required for hydropower, that based on that this is the requirement of power, and as per your you can say the final outcome is your unit rate, that is achieved through these power potential study. And for flood control, obviously for flood control we do the this simulation, description of flood problem in tributaries, subbasins, interstate, international aspect of flood drainage problem, flood data, flood damage, existing storage and flood control works in tributaries, flood control by the proposed reservoir, determination of flood storage, reservoir operation policy, and rule curve. Now we come to the design aspect. So for design aspect, dam design is done. So for dam, pier, spillway, stilling basin, outlet, etc. These are designed. Barrage, weir and head regulator, canals, canal structures, powerhouse. So this is a typical project layout. This is I think the DPR. This is not construction drawing. Construction drawings are very detailed drawing. These are either PFR or DPR stage drawings. So PFR or DPR stage drawings, they are not used for the construction. For construction, detailed drawings are fabricated and detailed design is done for construction purpose. So this is a general, you can say, the project layout. Here you can say the flow from this side, and these are the your piers. These are the piers, and gate, here the gates are gates should be there, because gates I have not shown here. So, and right head regulator, left head regulator, these sides head regulators are here, left head regulator and right head regulator. So if you want to ask any question, yeah, because you are not asking questions, so, and if you have any question, you please ask any. This is the first time you are attending any kind of DPR preparation workshop. Okay. So this is the PFR at PFR stage. Let me show you that how many chapters. This one is these are the chapters in the PFR. Your introduction, there should be introduction of your whatever the project you have planned. Introduction chapter should be there. Field investigation, which you have done. Then hydrological and geological investigation, irrigation power potential studies, design, cost estimate, economical and financial evaluation, and then at last BC ratio. So with the BC ratio, if you have reached to the BC ratio, and if it is more than 1, then your project is feasible, and it may be multi-purpose project, irrigation project, or whatever. So these are the basic required chapter in your PFR. I will show you finalized PFR also of a few projects. Just a second.
जो